Mr. Right here, and welcome to this film on bounds. In this film, I am working my way through some of the harder GCSE questions on bounds about grades 7, 8, 9. If you'd like to, you can hit the link in the description and download the questions, and then you can work on them either before you watch the film or whilst you are watching the film. Entirely up to you. If you are enjoying this content, please hit like and tell me so. Give me some positive feedback. Any questions? Then leave them in the comments, and of course, I'll respond. And if you are finding my content useful, then hit subscribe. Right, let's get on with the maths. Question 7. I've got a right angle triangle here, so I'm thinking about Pythagoras and trigonometry. I'm given the length of A is 5.3 centimetres. Look at that, correct to the nearest millimetre. So I'm going to just do a bit of careful thought here, because 5.3 centimetres is 53 millimetres. And my A is correct to the nearest millimetre. So I'm going to think about things in millimetres here. So the upper bound is 53.5 millimetres, and the lower bound is 52.5 millimetres. However, at the end of the day, I'm working in centimetres. So I'm now going to convert that back into centimetres, because I'm really going to want to work in centimetres for this question, because my answer's in centimetres. Look. Right, let's look at B. Now in B, for B, they've introduced, there's the same complication there. It's 8.2 centimetres to the nearest millimetre. So that's going to be 8.25 as an upper bound and 8.15 as a lower bound. And those are both in centimetres, because I haven't converted to millimetres and back again in that case. Calculate the lower bound for C. Well, how am I going to work out C in this case? I've got A and B, so I'm going to use Pythagoras. So I'm going to use C squared equals A squared plus B squared. Now I want the lowest possible C. So I'm going to use the lowest possible A and the lowest possible B. So C squared will be 52.5 squared. It won't do, of course. I've gone into millimetres there. So let's stick to centimetres. 5.25 squared plus 8.15 squared. So that gives me a C squared of 5.25 squared plus 8.15 squared, 93.985. So that gives me a C of the square root of 93.985, which is, now I'm going to give my answer 3 significant figures on my calculator. I've got 9.6945 and so on. 3 significant figures, 9.69. Will it round up? No, it won't. 9.69. And that's question 7 complete. Question 8. Again, I've got a right angle triangle here. And again, I've got A in centimetres, but correct to the nearest millimetre. So I'm going to need to be slightly careful. So if A is 4.1 centimetres to the nearest millimetre, then that's 41 millimetres, isn't it? So it's going to have to be 41.5 millimetres as an upper bound. So that's 4.15 centimetres. And it's going to need to be 40.5 millimetres as a lower bound. So that's 4.05 centimetres. And I'm going to do a similar thought here. I've got 10 centimetres there. Correct to the nearest centimetre. So don't fall for that trap. So it's 10 centimetres correct to the nearest centimetre this time. So that's 10.5 centimetres an upper bound and 9.5 centimetres as a lower bound. They're really playing you and your units in this question. Calculate the lower bound for B. Now, how am I going to find B in this case? Well, I'm going to use Pythagoras, and B is going to be the square root of C squared minus A squared. Now, be very careful. They want you to find the lower bound for B, so it would be easy to think, well, I'm going to use the lowest C and the lowest A. But that is not the case, because you want your answer for B, the square root of this bracket, to be as low as possible. So that means that you want the contents of this bracket to be as low as possible. So that's going to mean that you want the lowest possible C squared, but the highest possible A squared, because only then will the contents of the bracket be as low as they possibly can. So the lowest possible C squared, 9.5 squared, minus the highest possible A squared, 4.15 squared. So this is what we need to be working out. So 9.5 squared minus 4.15 squared. That gives me the square root of 73.0275. And when I square root that, I'm going to get a long number on my calculator, I'm sure, but I need to give my answer to one decimal place. So I'm going to show the examiner a few of the digits. That'll do. To one decimal place, my answer is simply 8.5 centimetres. And that is question 8 finished. Question 9. Right, I'm given a formula for P, which is E divided by T, and I'm given some information about E and T here. Let's have a look. Let's work out my bounds. So E is 812 correct to 3 significant figures. So the upper bound for that is going to be 812.5, and the lower bound is going to be 811.5. Meanwhile, I'm given T correct to one decimal place. So the upper bound for T is going to be 9.25 and the lower bound 9.15. Okay. By considering bounds, work out the value of P to a suitable degree of accuracy. So what it wants to know really is to what degree of accuracy can I go without it making a difference whether I'm upper bounding or lower bounding. Let's have a look. Let's first of all, on the left-hand side here, let's work out the highest possible value of P. Now, the highest possible value of P is going to be the highest possible E divided by the lowest possible T. So that is going to be 812.5 divided by 9.15, which incidentally is 812.5 divided by 9.15, 88.79781, and so on. Now, on the right-hand side, let's work out the lowest possible P. The lowest possible P, well, that's going to have the lowest possible E divided by the highest possible T. The lowest possible E is 811.5, and the highest possible T, 9.25. Right, 811.5 divided by 9.25, that gives me 87.729729, and so on. Okay, so we've worked out the value of P. We've worked out the upper bound of the value of P on the left and the lower bound of the value of P on the right. So if I gave P to one significant figure, on the left-hand side I'd have 88. Well, that's 90 to one significant figure, isn't it? On the right-hand side, I'd have cut off after the 8, so that would be 92. So one significant figure is fine. I get the same answer, both with the upper bound and the lower bound. Let's try two significant figures. Can I push it further? Well, the left-hand side, the upper bound to two significant figures is 89, and the lower bound to two significant figures is 88. Look, I've got different answers. So I can't go as far as two significant figures. So all I can say about the value of P for sure is that it is 90 to one significant figure. I can't go any further than that. Question 10. I'm given a formula for f here, the square root of g over h. I'm given some information about g and about h. Now, g is equal to 12.17, correct to three significant figures. So to 12.7 correct to 3 significant figures. So the upper bound is 12.75 and the lower bound is 12.65. H, meanwhile, is given as 9.294 correct to 3 decimal places. So that's going to be an upper bound of 9.2945 and a lower bound 9.2935. Right, by considering bounds, work out the value of f to a suitable degree of accuracy. So on the left-hand side, I'm going to work out f, the highest possible f, work out the upper bound of f. And on the right-hand side, over here, I'm going to work out the lowest possible f. And then we'll see where that gets us. So on the left-hand side, working out the highest possible f, I'm going to want the highest possible numerator and the lowest possible denominator. So the square root of g, I'm going to use the upper bound of g. So that's going to be the square root of 12.75. I'm going to divide it by the lowest possible h to give me the highest possible value for f. So let's just work that one out. So I'm going to use my fraction and then square root on the top, square root of 12.75, and on the denominator I'm going to go 9.2935. Okay, and that gives me 0.384,216, and so on. Now let's work out the lower bound for f. Let's do that over here. Obviously it's still going to be the square root of g over h, but I'm going to use the lowest possible value of g and the highest possible value of h, because that's how I'll get the lowest possible value of f. Lowest possible value of g is 12.65, so I'm going to have the square root of 12.65 over the highest possible h, 9.2945. Okay, put that in my calculator. Use the fraction, square root on the top of the fraction, 12.65, and on the denominator, 9.2945. That gives me 0.3826654. Right, let's have a look at these answers here. So I've got the upper bound of f on the left and the lower bound of f on the right. If I work to one decimal place, then the upper bound on the left is 0.4, and the lower bound on the right is also 0.4. Look at that, so that's good. What about if I push it to 2 decimal places? Will I get the same in both cases? Well, on the left-hand side, the upper bound, I get 0.38. And on the other side, look at that, I get 0.38 as well. So I can go to 2 decimal places. Can I push it to 3? On the left-hand side, to 3 decimal places, that would be 0.384. And on the right-hand side, I get 0.38, not 2, because it would round up to 3. But they ain't the same, are they? So I can go as far as 2 decimal places. So work out the value of f to a suitable degree of accuracy. Well, f is 0.38, and my suitable degree of accuracy is 2 decimal places, because if I go any further, I end up with different answers for my lower and upper bound. And that is question 10 sorted out. Question 11. Okay, I'm given a value of f, and I'm given a value of a, and I'm asked to work out, by considering bounds, the value of p to a suitable degree of accuracy. And here's my formula for p on the right-hand side. Now, first of all, let's work out my upper and lower bounds for f and for a. Now, f is 25.14, correct to 2 decimal places. So the upper bound for that would be 25.145, and the lower bound would be 25.135. And what about a? Now, a, the error is given to me correct to 3 significant figures. So the upper bound will be 4.295 and the lower bound 4.285. Good. Now, I've got to work out the value of p to a suitable degree of accuracy. Well, on the left-hand side, I'm going to work out the highest possible value of p, the upper limit for p. Now, if I do that, p is f over a, I'm going to need the highest possible f and the lowest possible a. And on the right-hand side here, I'm going to work out the lowest possible value of p. And to do that, I'll need the lowest possible f and the highest possible a. So let's do those, and then we'll see what's going to happen next. I'm going to split my page in two here. So on the left-hand side, the highest bound for the value of p is going to be the highest f, 25.145, and the lowest a, 4.285, which is going to give me 25.145 divided by 4.285, 5.868,144, and so on. Now let's go to the lower bound of p. That's going to be the lowest f, 25135, over the highest, the upper bound for a, 4.295. Okay, 25.135 divided by 4.295. Okay, that's going to be 5.852153, and so on. Okay, so we've worked out the upper bound of p and the lower bound of p. Now we need to, our answer has to be the value of p to a suitable degree of accuracy. Well, I wonder what degree of accuracy I can give a guaranteed value of p. If I go to perhaps nearest whole number, well, the nearest whole number, the upper bound of the value of p would be 6, looking at the value on the left and putting it to the nearest whole, and I'd also get 6 if I looked at the lower bound. Great. So what about if I go to one decimal place? Well, if I go to one decimal place, the upper bound for p is 5.9, and the lower bound, look at that, it's 5.9 as well, isn't it? Because that 8 rounds up. So I could go to one decimal place and tell you for sure that p is 5.9. Can I go to two decimal places? Well, the upper bound to two decimal places, the cutoff point is after the 6, that's going to be 5.87. And what about the lower bound? It's not going to be the same, is it? It's 5.85. So I can't tell you a guaranteed value of p if I go to two decimal places. So I can tell you, though, that p is 5.9 to one decimal place for sure, and that is the answer for number 11. Question 12. Right, let's have a look at this one, shall we? We've got a value of f, which is given correct to two decimal places. So the upper bound of f will be 20.815 and the lower bound 20.805. And I've given p correct to three significant figures. So the upper bound of p will be 5.125 and the lower bound 5.115. Okay, by considering bounds, work out the value of a to a suitable degree of accuracy. Work out the value of a. Look at that. And they haven't given us a formula with a as the subject. So let's take that formula they've given us and let's rearrange it to make a the subject. So a is going to be f over p. I like to throw in an extra trick there. So I'm going to use the formula a equals the value of f divided by the value of p. Right. So now I'm going to work out a to a suitable degree of accuracy. So I'm going to work out the upper bound of a over here. And over here, I'm going to work out the lower bound of a. Now, when I work out the upper bound of a, given that a is f over p, I'm going to need the highest f and the lowest p. And when I work out the lower bound here, f over p, I'm going to need the lowest f and the highest p. So let's get on and work out the upper bound of a. The highest f is 20.815 and the lowest p is 5.115. So I'll use my calculator to work that out. 20.815 divided by 5.115. Okay, that's 4.06940 and so on. Now the lower bound of A, so I want the lowest possible F, and that's 20.805, and the highest possible P, 5.125. Okay, 20.805 divided by 5.125 gives me 4.0595 and so on. Okay, so I need to give, the answer is, what's the value of A to a suitable degree of accuracy? Well, if I work to the nearest whole number, then I get the same value for the upper bound, 4, as I do for the lower bound. So if I was working to the nearest whole, I get 4 for my upper bound and 4 for my lower bound. So I can definitely say that A is 4 to the nearest whole number. Let's go to one decimal place now. On the left, if I put that number to one decimal place, I get 4.1. So the upper bound of A is 4.1 to one decimal place. And the lower bound of A, look at that, 4.05, that's also 4.1 to one decimal place. So I can tell you for sure that A is 4.1 to one decimal place. Let's see if I can tell you for sure what A is to two decimal places. Well, on the left-hand side, I get 4.07. And on the right-hand side, I get 4.06. So I can't tell you for sure the value of A to two decimal places. So what can I tell you about A? I can tell you for sure that it's 4.1 to one decimal place. But any more than that, I cannot say for sure. And that is question 12 finished. Question 13. Okay, I'm given a formula for V here. And I've given some information about some of the variables, about the V, the A, and the S. And I'm asked to work out the upper bound for U. First things first, let's work out the upper and the lower bound of each of our variables. Now, V is 35.2 to one decimal place. So the upper bound is 35.25 and the lower bound 35.15. A, meanwhile, is 9.8, correct to one decimal place. So 9.85 and 9.75. And S is 60.35 to two decimal places. So 60.355 and 60.345. Now I'm asked to work out the upper bound for U, but the formula that I'm given has V as the subject. They don't like to make it straightforward, do they? So I'm going to rearrange this formula to make U the subject. I'm going to start by subtracting 2as from both sides. That's going to give me v squared minus 2as equals u squared. So then I'll square root both sides, which tells me that my formula for u is the square root of v squared minus 2as. Okay. Now I've been asked to work out the upper bound for u. The upper bound for u. So I want the highest possible u, please. So that means that I'm going to want to square root the highest possible number to give me the highest possible u. So that means I need this number in the brackets to be as high as possible. Well, if I want v squared minus 2as to be as high as possible, I'm going to choose the upper bound of my v squared minus 2 times. Now I want to take away as little as possible from v squared, so I end up with as high a number as possible in the square bracket. So I'm going to choose the smallest possible a and the smallest possible s. So now I know exactly what I'm doing. I can simply substitute in my values here. So my value for v, I wanted the largest possible v, 35.25, minus 2 times the lowest possible a, 9.75, multiplied by the lowest possible s, 60.345. Good. So now it's just a question of putting these numbers into my calculator. Incidentally, it was 35.25 squared. I hope you noticed that I made that error there. Minus 2 times 9.75 times 60.345. So let's have a look. 35.25 squared minus 2 times 9.75 times 60.345 gives me an answer of the square root of 65.835. So my upper bound of u is going to be the square root of 65.835, which I've got on my calculator. And I'm asked to give the answer to 3 significant figures. So I'm going to square root 65.835, which I had on my calculator, which gives me 8.1138, and so on. And so to 3 significant figures, there we go, my answer is going to be 8.11. And that is my answer to question 13. Well done for reaching the end of the film, and thank you for watching. I hope you found the film useful. If you did, and you'd like to see more of this sort of content, then hit subscribe. All right, see you in the next film.